In this session of us today, we will be trying to solve one board exam problem under the category of hydraulics and geotechnical engineering. And this is our problem number 1. First and foremost, allow me to read the problem. A 1.25 centimeters diameter orifice in a vertical wall of a tank under a constant head of 5.5 meters discharges 0.45 cubic meters in 9.5 minutes. Find the coefficient of discharge. And for the choices that are given to this board exam problem, we have letter A, 0.62, B, 0.42, C, we have 0.58, and letter D, 0.60. This type of a problem is actually under the concept of orifice, under the chapter of the orifice topic in your hydraulics subject. Now, what do you think will be the steps in solving this given problem? How do you analyze the problem now? I'll give you 5 seconds. 1, 2, 3, 4, 5. Now, if you think that in order to solve this given problem, in order to calculate the coefficient of discharge, we have to calculate first the theoretical discharge followed by actual discharge. So meaning, we have 3 steps in order to calculate this given problem. First, we have to calculate for the value of the theoretical discharge. Second one, we have to calculate for the actual discharge. And then for the final step, we can then calculate the coefficient of discharge, because the coefficient of discharge is actually equal to actual discharge divided by theoretical discharge. Let me repeat. First, we have to calculate for the theoretical discharge. And for our second step, after calculating the theoretical discharge, we have to calculate for the value of actual discharge. And then of course, finally, for the last step, we have to calculate for the coefficient of discharge. Let us now start solving the problem. At first, we have to calculate for the value of the theoretical discharge. And the formula that we use so that we can calculate the theoretical discharge in this orifice problem is Q sub T equals A stands for the area to be multiplied by the 2 times G times H. By the way, the value for G in metric system is always 9.81 meter per second square as a constant, and H stands for the head. In the given formula, A stands for the area, and the area formula that we have is actually pi d squared over 4. That is why our theoretical discharge formula now is equal to this. Q sub T equals pi d squared over 4 times square root of 2gh. Coming up next, we have the direct substitution to the formula. The value for G is 9.81 meter per second square, while H's value as the constant head is equal to 5.5 meters, and the diameter of the orifice is 1.25 centimeter. To be converted into millimeter, 1.25 centimeter is also equal to 0.0125 millimeter. Finally, our answer to our theoretical discharge is 0.001275 cubic meter over seconds. Since we have already computed for the value of theoretical discharge, we can now start computing for the value of our actual discharge. And of course, our formula for computing the actual discharge, we have volume over time. In doing the substitution process, we have now our equation as Q sub A equals 0.45 over 9.5 times 60. 9.5 times 60 because we have to convert minutes to seconds. And as we all know that 1 minute is equal to 60 seconds, that is why our denominator is 9.5 times 60, while 0.45 cubic meter is the volume. Finally, our answer to the actual discharge in this situation, Q sub A equals 0.0000789 cubic meter per seconds. And for the last step of our calculation to this given board exam problem, we can now compute for the coefficient of discharge. Our coefficient of discharge formula will be the ratio of the actual discharge to theoretical discharge, or Q sub A over Q sub T. And then, by direct substitution, we have our coefficient of discharge as equal to 0.000789 over 0.001275. Finally, our answer to this given board exam problem, our coefficient of discharge is equal to 0.62. Thank you very much and God bless us all.